I was studying geology, and I find this concept of talus. This is or scree, as they say. This so interesting that I decided to record this video. So today we're taking a quick look what a talus is and how it forms in nature and why it matters in civil engineering. Well, a talus is a natural build-up from broken rock fragments that collects at the base of the step or of step slopes or cliffs. It forms over time through physical watering as pieces of rock crack off and fall under the force of gravity. These deposits often form slopes with angles between 30 and 40 degrees, close to the natural angle of repose. From an engineering perspective, Talus is a potential hazard. It's loose, unbounded, and highly unstable, especially when water steps in. That makes it prone to landslides, rockfalls, or even flows, uh, where the material moves like a slurry of mud and rock. Well, uh, this is a very a very big matter and problem in civil engineering. If you're building near a mountain, there's three main types of failures we might see in this case. So the first one is planar sides along weak surface in the rock. So will be a planar slips. No? Or the material will slip in a planar surface. Rotational slips, more common in clay or mixed materials. So there will be a rotational mass going down, or and debris follows, often triggered by heavy rain or poor drainage. So it's more, I think it's more understandable. Well, and in engineering, as we the works of civil engineers to solve problems. The, to manage this risk, engineers apply a range of solutions. I'll talk about three of them, three of them that I remember. The first one is surface and subsurface drainage to keep the material dry, because if it is uh, wet, it will slide and make a mess. And the second one is retaining walls. You often see retaining walls in motorways as you go by car along the country. You often see that near mountains, of course, in the mountains. Well, retaining walls, rock for fences or gabions to hold material in place. And of course, revegetation or geotextile meshes to control erosion. That's uh, very interesting. Is getting into the market. Geotextile meshes are really a good choice, I think. But it depends on the case, of course. And in critical areas, the removal or reshaping of the talus itself. So you just remove this material. Of course, if you can, you must make an analysis if the material continually been falling down from the cliff or no, it's stabilized, it is stable. So there's many variables in these situations in geological and civil engineering. Well, in short, while Talus is a natural geological feature, it must be carefully assessed and stabilized to avoid problems in infrastructure works, especially on highly or mountainous regions. So that's it. That's a concept, a really interesting concept in geology, and I find that very interesting. I just show you, going to show you two images to understand this concept of talus. Here you can see in the on the top left this mountain and the formation of talus by the breeze and air, and on the top right, you can see another talus in another formation of mountains. But as you can see on the on the floor, it's not the right to say the floor, but here on the floor, you can see the grass has grown up over the debris. So the grass, the vegetation is helping to keep this material hold all this material together and to avoid erosion. This is quite important. And down here, there's this illustration about the most common uh, um, uh, ways that the talus happen in nature. They often form a cone, as I said, as and likely to have 30 to 40 degrees angle, because after 40 degrees angle, the metal will just fall and go down. It will not stop on the talus. It will go down and over time get the talus higher and bigger, but not with a higher angle, just with a higher size. You understand? That's quite interesting. So that's it. I hope you like it. And thank you for watching. Bye.